Tonight we're up in the food shop, the kitchen. I have a little stew going here in the ultrasonic crock pot. These are some components to a mandolin and a frycutter I got recently. Both of these guys came out of a restaurant that was shutting down, so they are the real deal, heavy duty commercial grade gear. They've also been pretty heavily used and abused in that restaurant environment. But I'm hoping with some TLC, I can get them back up and running for use in my kitchen. Now I'm very excited to have these guys, because I've wanted these both for years. I just put that purchase off because, to be totally honest, a mandolin and a frycutter are absolute overkill for any home chef. But there ain't no killing overkill, so here we are. Now I have this guy taken apart, finally. That was an absolute bitch and a half to do, but I have it on video so I can show you guys that. And the next steps will be to clean off all that caked on crud and grease here, and then go to McMaster to order some new hardware to replace all these rusted out and worn down bolts. And I can put this guy back together and see if he's up to the task at hand. Because in this kitchen, it's sweep potato fries or bust. This thing is being a bitch and a half to take apart. I already brought it down from the kitchen to the shop and I'm still having trouble with it. I gotta say, the selection of fasteners in this thing is not terribly impressive. For example, this is one of the bolts that holds the top pressure plate onto the casting. Just plain steel, flathead screwdriver, really easy to strip. Could not get a screwdriver to engage for the life of me, and ended up using vice grips to pull it out. So that one goes here. There's one more down there, which I can't get with the vice grips, not until I get this whole thing taken off the rails. And the actual lever for it itself goes into this little pillow block, which is then bolted into these two holes with one of these guys. So for all the force the handle's supposed to, translate to the, the top pressing plate, this bolt seems pretty small. And in fact, there's only the one of them because the other one had already snapped off, come loose, whatever, and was missing. So obviously, it's not necessary to have them both because they were using it with just the one, but it just seems like it's a little bit of underkill here. And of course, having the open hole, this one just gets full of crap. And that seems to be a problem throughout this whole design. I really would have liked to have seen those all be stainless, just because these things are used, in the kitchen, nearby food, with lots of moisture, getting washed and all that too. There's no reason to, go for steel that's going to rust up eventually, when you could spend a bit more on the materials and get stainless. These frycutters new cost between $200 and $350, so there should be money in the budget for a couple of stainless fasteners. Now, one place I did use stainless was on the bottom of this, or on this tray here that holds potatoes. So two here that came out, nice and easy. These guys, yeah, not even tough to turn. But then down here, again, just awful, awful design and positioning. These guys got right full of crap from all the potatoes being cut right here, and they should have seen that coming. And it would have been an easy enough fix to have just bent the bottom of this tray, just so you can, then bolt on the back side of the casting. Now I know that having this thing bolted into the casting on this side does provide a good bit of strength to, the whole thing. The only things connecting this half and this half are the two rails, the tray, and ideally you having this bolted to a large, chopping block or something like that. So the chopping block really should provide most of the strength. But if you're not doing that, then, this tray has to make up for a lot of it. So if you had this thing bent and then on the back, it might be a little bit weaker, just a bit more prone to torquing. But then a pair of bolts in each tab would have done it just as well. And that would have kept these things shielded, out of the food, so it would be easy to remove. Now for the actual fastening on the rails, we got a pair of set screws up here, just little flathead ones. And then up here we have pins. So that's a strange design to have set screws on one end and pins on the other. And the pins don't go all the way through. And in fact, this one doesn't go all the way in. And I thought at first that the holes in the insides might have been through holes lined up with the through hole on here, and the pin is a bit short and possibly still able to get knocked out. So I thought was I'd take a cheap 3-cent Chinese drill bit, cut the drilling part off of it, and just have that as a little rod that would fit the hole. I could tap it through and knock the pin out. But you can see that it only goes in about as deep as the casting. So I'm assuming this pin here does actually engage with a detent on the rail. In which case I'm not sure how to remove this one, or especially this one. But I guess worst case scenario, if I can get the rest of it all taken apart, I do not need to remove the rails to clean, this part and this. Just need to remove the bottom half of the casting from the rails. And the current predicament is removing the bottom blade plate. So this guy is just jammed on here. It was only held on by two nuts I've already removed. And you would imagine that it would just slide right off, but with the amount of gunk that's built up in it and corrosion on here, it's not coming undone. So we don't want to tap it too hard with the hammer because castings are fragile. But I think I finally came up with a solution with one of my fancy welding clamps. So this guy can be turned around to make it into a spreader as well. So doing this just barely fits and just might work, though I do need both hands. So I have this guy cranked pretty tight right now, and I'm not sure how much further I can go. I'm basically relying on the strength of these pins to hold these two parts of the casting in place so I can actually push against the bottom blade block. Right, these pins are holding the bars in. I've already removed these screws. This is not bolted to the plate. If I really need to, I can, bolt this to the plywood. I could do that if I need to, but I do see this just barely starting to separate now on this side. So I might have some luck if I loosen this up and come back with a plastic wedge and just tap that in there and then do the whole back and forth thing until it finally comes free. So my wedge wasn't really working against the casting here, but I thought, well, why not try it against the bottom side, or I might have more space. And sure enough, there actually is more space down here, and it is right full of, dead potato detritus. Isn't that lovely? Ooh. So it is coming loose slowly, if you can see the light creeping in right in there. But I'm not exactly pleased with the progress so far. So the thought that if I could make this bottom half of the casting move independently, like up the rails, then this would be much, much easier to free. And since I've already undone these two stainless steel bolts down here, this can remain bolted on. All I'd have to do is loosen up these set screws and then get the casting to slide on the rails. Of course, these set screws are also #awful engineering because their placement is just, again, I don't understand why. Because this one here turned okay, but this one here is already all gummed up, and rather than turn, it just stripped out immediately. So now I'm going to bring out solvents and just keep trying different solvents and greases till something works and see how that goes. This is edible, right? I will say, I do love dental picks for getting in tight little places like this and removing little bits of garbage. Like, I didn't have them for the longest time, and I did not know what I was missing out on. This one here came with my 3D printer. Best $1,300 I ever spent. So you know that thing when you say you're done for the night and you quit, but like 10 minutes later you get annoyed at quitting and you go back and keep on working? Yeah. But at least cutting blocks off now. Yeah. You can see the problem is, as I thought, all this gunk here, this hardened, crusty, anyway, all that was practically gluing it to the face of the casting here. You can see how nice and clean this is and how, like, I wouldn't ever want to touch that. Yeah, so, oof. Anyway, that was the problem. The answer was heat. So I pulled out another kitchen gadget, the Bernzomatic 4000, I think, which I use for browning steaks mostly. But pulled that out, a little bit of gentle heat. And I screwed the thing down to the plywood beforehand, and then with the heat and a little bit of the tap, 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 and it came loose. And one thing I noticed about the design here is that this rod turns down to one constant thin shaft, whereas this one here has a shoulder, which engages on the counter bore, if you can see that, inside the blade block. So that counter bore gives it more surface area to contact on and help it keep square. And then also when it rusts, because not using stainless, it gives it more contact area to seize up against. Fantastic, right? And then the design of this too means you can't turn the block around, which is important because most potatoes, they're not going to fill this entire space. They're going to be a bit smaller, right? This is let's see, like 3.5 by 3.5, I guess. Yeah, most potatoes are not that big. So you're going to bias your cuts towards this part of the blade and then wear it up prematurely. Normally, I would think you just take like the whole thing and just rotate it over, right? That way it'll now be biased towards the other side of all the blades. But the design keeps you from doing that. So I guess that way your things wear out faster and they can sell you more replacements. Now that is engineering. So you know that thing where you say you'll start your project up again in the morning, but it takes you 2 weeks to get around to it? Yeah, but I'm at it now, so time for more video. The next steps in disassembling this guy will be these two bolts here and the set screw up here. So these guys are already jammed up the shmoo, but I did find I can get them loose with a center punch and a hammer. I can't exactly demo here because I'm working one-handed, but the idea is if you get the center punch to bite in on the edge of that screw, when you tap it with the hammer, the impact will slowly turn it around. And you can already see where I've done that a bit and gotten maybe a quarter turn out of it so far. So if we get that out all the way, I can compare the threads and find a suitable replacement. I know it is nice having the pan head here, so that way any potatoes coming down the chute don't get snagged up on it. But I'm thinking I might just go with the hex bolt to replace it, because that way it'll be easier to remove in the future if I have to. It's a bit more in the way, but it doesn't have that internal drive here to get gummed up with potato the way the Phillips drive here does. Now as for the set screws, I've already stripped this one out earlier when I was working 2 weeks ago. I since came back and tried to drill it out a bit with the left-hand drill bit. It did not loosen it up at all, but it did manage to make a royal mess of things. So I figure I'll keep drilling that until it's just little bits I can get out of the way, and then this should be all frayed up. So I'll replace these two set screws probably with just other 1/4-20 set screws. But I'm thinking I'll not actually use them for tightening them down and just use them more as a plug in that area. So put a little bit of blue Loctite on it, turn it in there just so it's sitting flush with the casting, but not actually use that to cinch these rails down to the casting body. Instead, I can come in from the side and drill a second hole, tap that 1/4-20, and use those as actual set screws for securing this in place. The reason you want to have them on the side is that those ones will be more protected from the potato gunk, and they won't get all jammed up, so they'll be easier to undo in the future if I need to. Right? Just putting them here, when putting them here would have had the exact same holding force, been much more shielded from food bits. It was a bad idea. So I'll just plug these up and redo them where they should have been in the first place. Let's see. I also know that this thread here is a standard 5/16 thread. I came in with some calipers and checked that. Now, if you are measuring out threads per inch with a set of calipers, I personally find it easier to use a spreading side, where you can kind of situate one of the teeth in the root of the first thread, and then count out as you pass the rest. 1, 2, 3, 4, 5, 6, and 7. And you can do some division, and you get your threads per inch. Now, since this is a standard size, I actually happen to have wing nuts on hand. They're not stainless, but I figure, at least in this position, I'll be taking them off and on regularly enough to clean the cutting block that I can always inspect them and then replace them, very quickly and easily if they do start to show signs of, rusting and wear. Okay, those bolts are out, the chute is off, and the set screw has been drilled away to the point where I even damaged the rail just a little bit underneath. But even with all that, I could not separate this half the casting from the rest of it. So I thought the problem was probably corrosion, again on the rails here. And I decided that rather than trying to lift it off, I'd first try to push it down to expose this and let me clean that corrosion off and hopefully introduce the play I need to actually separate this half the casting. Now with the heat and the hammer not doing anything, I went to my next trick, which is the 20 ton Harbor Freight press. So I'll set this guy up here in a block, took a piece of pipe and made a little spacer and just applied not very much pressure at all. Like, did not take any real oomph whatsoever to push that down. But it did manage to move it about 3/4 of an inch, nice and gradually without cracking anything. So yeah, with that, hopefully I can clean this guy up and carry on. Now, I will also note that all this white dust came out of it when I flipped the thing over. It was all inside this block. And I quite honestly have no idea what the fuck that is or how it passed the health inspection in a restaurant. But there's some of it right there, and there's actually a whole little pile of it here on the floor. And I really just don't know what that is, and I'm kind of looking forward to, kind of scared of the moment when I get this presser plate separated from the backing and I see what exactly is living inside of here. Yeah. Well, that answers that question, or maybe just introduces more, because I have no idea what this is, but it was entirely filling this part of the casting here. So this is what presses down on the plate that forces the potato all the way through the blades. And yeah, it's just full of all this dust. And there's little bits of kind of solid powderized stuff that does break up under finger pressure. So, I don't know, maybe they filled it with sand intentionally to like even out the pressure from this guy pushing down, like spread it out better on the casting. As for the retaining pins up here, I'm pretty sure I can pull this one out because it's exposed on the back side, but this one here will be drilled because it's flush with the casting body and there's no access from here to knock it out. When they're gone, I'll have to replace them with other pins, I think, just because up here we require kind of a stronger retaining system than that end. Down here they got away with these set screws, which are kind of a weak retainment, but they could do that because there was the cutting block over here and then the threaded ends with the nuts. So those nuts provided the backward pressure to keep the force of the pressing plate and the potato going through the cutting block from actually pushing this casting off that end. Up here, there's really nothing keeping this casting from being pushed off this end apart from these retaining pins. Now they could have made these rails like another inch longer or so and just threaded that part and had another set of nuts up here, and that would have provided better retainment. Then set screws would have been fine here the same way they were down there. But that would have required, thinking design through and being somewhat competent. So you got these rails off, and with that, the disassembly is pretty much done. I began with the half I had to drill out, and I used an automatic center punch to give myself a good center on the face of that pin. So basically this thing here has a threaded portion you can use to adjust the pressure, and when you push down on it, it gives a little love tap. And that can give you a very nice spot to start your drill. Now if you turn this thing all the way down, then it takes quite a bit more, but can still give you a very nice, precise hole start. So I used that to give me a fighting chance, drilled at the pin, at least what I thought was all the pin, and then with one good smack with the 3/8 inch rod and the hammer, that thing came right out. On this side, I repeated the same process because I could not get a grip on it with the pliers, but I just filed it down so it was flush, and then, again, easy peasy. It was probably the easiest part of this whole disassembly, to be honest. But anyway, now that these things are out, I'm actually not sure I removed all the pin. Because you look here, right there, and there, and again on this other one, it seems like that pin is actually still in the rail body. Now that's typically how it would work, right? The pin would come through the casting, through the shaft, and then out the casting again. But I'm a bit confused because I didn't see the pin on either of these two faces of the casting. I only saw it from the outside faces. So it appears to me that they simply didn't line up the pin and get it through, all three parts here, not through the casting, the shaft, and the casting. They just stopped when they couldn't line it with the last hole. Now, maybe I'm ragging on Vollrath pretty hard. Like, I know I am right now, right? And I'm not sure what issues here were their fault versus like some changes done after market by the former owners, right? Like some of the bolts that were steel and rusted out could have been bought to replace other bolts, for example. But on the other hand, if that was the case, then those bolts are still bought to replace bolts that weren't up to par in the first place, right? And if the former owners reinstalled this pin and just didn't bother going all the way through, well, there was still a pin to install as opposed to a threaded rod with a nut up here that would have been simpler anyway, right? So maybe the blame isn't totally theirs, but I don't know. I think they did a pretty shitty job, and I stand by that verdict. Now, as for the cutting block, I'm not sure this guy can be saved. I spent some time clearing out, some of the crap that was stuck on here, and as I was doing that, the aluminum casting just began chipping apart. Little bits of it falling off here, 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 here. It is seriously corroded, and if too much of this wears away, then it's not going to hold the blades in very securely, and the problem will just get worse. So that might need to be replaced, but luckily, a replacement was actually included with the auction. I guess the former owners had this on hand as a replacement one for that, but they never got around to putting it on because clearly that one there did not want to come off. So if you take a look at this new one here, we can see how clean these faces should be, and the blades are just stainless steel, kind of interleaved with each other, and they are held in by pins that I guess are accessed through the holes in there. So I am going to keep taking this one apart just for, for fun and whatever, and maybe it can be salvaged at least as the backup for the new one. So I've already started doing that by applying some heat to this side to help break it up a little bit. Coming with the dental pick and clearing out, this hole and this hole, because obviously they were also full of gunk. And then I began tapping out the retaining pin there with the drill rod, same way I thought of before. And now I'm coming in with a full-blown drill bit and tapping that down as well. And I've reached about the limit of what that drill bit will do, but I figure a bit more tapping just to the last little bit and then pull it out with pliers before it goes too far. And the same on this side with some more heat applied. And, that should come out. Not too bad. Oh, there it goes. There it goes. Yes. Oh, shit. These are the blades from the cutting block. Half of which have the notches in the blade side, and the other half of which have them in the back side. That way you can interleave them and drop them here in the block. And there's also these short pins here, which go into the kind of lattice before you drop it in here. So they fit in this one and this side. And once that's all in place, then these longer ones here and this one get fed in from here and here to lock it all in place. Now, having this apart does answer, at least give me a good hint on two questions of mine. One of which is, are these things sharpenable? And it seems to be the answer is yes, so long as you don't let them go so far that you have this issue on your hands, right? So with that new block there, if it gets dull, and I'm quick about it and don't let it get all mucky and stuff, I can take the blades out again and just give them a few strokes on a whetstone and bring it back to sharp. The other one is, can you remove every other blade and maybe get like a double-sized cut? And it seems like the answer is yes. I'm not so sure if it can like support the weight and the cutting pressure and all, or if that's actually useful. These here are for cutting, I think, 1/4 inch. I haven't actually checked yet. Yeah, 1/4 inch fries. And that's about good. 1/2 inch fries would be kind of, overkill and hard to fry. But yeah, that's glad at least get it taken apart. Though I'm pretty sure this one here is totally buggered and just due for the scrap bin. Oh well. Okay, this shit is bent together. Let's go over the new stuff and give it a shot. First off, you can probably tell the color here is a lot darker than it was before. That's because the nickel coating on a lot of the cast iron parts had gotten very thin, leading to rust. So I cleaned off pretty much all of it with the wire wheel and gave the whole thing a few coats of lard seasoning instead. So thin coat of lard, bake in the oven, thin coat of lard, bake in the oven, and repeat. Just like you would with a cast iron pan. Now to actually get it to be cast iron black with that like deep dark satin finish would probably take another 12 coats. And I'm not going to bother that much because this here is plenty enough just for, you know, basic rust resistance. We don't need a full-fledged non-stick seasoning here. Using lard for these few coats though does have the extra benefit of making sure that none of my fries ever end up accidentally vegetarian. Because I, for one, am deathly allergic to vegetarian food. If I eat it by mistake, I go into catabolic shock, my muscles begin to just waste away immediately. It's bad. So the number one way to make sure you never accidentally eat vegetarian is just coat everything in ample amounts of lard. Now, working from here up, we've got wing nuts installed to make the blade block easier to remove and clean. The set screws here have been reinstalled, but are not clamping down very hard. They are letting the wing nuts here do that work. I went and retapped the legs of this cast iron body because the threads here for holding the tray in place, they're what, 1024, and they used to go halfway down in the material here. But half of those threads had corroded away just from all the other, you know, general corrosion on this thing. So coming back in with another 1024 tap, I cleaned up what was left and put new fresh threads on the bottom half so I could use a longer screw and get some actual engagement. The screws here are 18/8 stainless steel, and they've got a combination Phillips and flathead. I figure that'll probably be the easiest one to dig the crud out of if I have to remove this tray in the future. See, coming back up further, we've got the same stainless steel combination flathead Phillips screws right here. I've got them shimmed with a little plastic washer just to make up some of the extra length. I only bought, you know, one box of 1024 screws from McMaster. I wasn't going to buy 3/4 inch and 1/2 inch because, you know, that'd be ridiculous. But of course, for the threads right here, I actually did have to buy another box of screws because these ones are 1224. The fuck? Nobody uses 1224. Everybody goes from 1024 to 1/420. The only place I know where 1224 is even remotely near semi-standard is in server racks. Like for a data center with like all the server computers there. Like those sometimes use 1224. But leave it to these guys to make every bad decision on the design of this thing. And at least if this screw or this screw eventually gets chewed up or whatever, I've got 48 more where that came from. Yay. Now here, to replace the retaining pins, I put a couple of roll pins. You know, one, because I had them on hand, and two, because I think they might do a better job of filling in any extra clearance I might have made by drilling out the old retaining pins. Now this whole guy is screwed down to this cutting board it came with, and then that is now screwed to a piece of 1-inch MDF. Formerly it was anchored to a wall. I'm not going to be doing that here in my house, but I think having this MDF will give it plenty of a sturdy base. And I came around with a router and a flush trim bit just to make that look all, you know, nice and pretty. And of course, there were more problems. Once I had this guy assembled, I found the fit here in the rails was so sloppy, there was zero chance that the teeth on the pushing block were going to clear the blades. In fact, if you look here at the old and corroded pushing block, you'll see just how tapered all these teeth are, as opposed to how square and rectangular they are on the spare that came with this thing. So basically, there's so much play here that every time the old owners were cutting fries, this is scraping against the blades, you know, wearing it down and shaving off little bits of aluminum into your food. Yum. Now, that was one thing, right, with the fry cutter mounted vertically, because with all that play, this kind of wants to move randomly within that range. Now, I have it horizontally, so rather than being within a range of play, it always wants to be at the bottom because of how forward heavy this component is. You see, this always wants to canter forward and then drag along the lowest part of the play. So what I was getting was the teeth right here and here fetching up on this portion of the casting. So I thought, fine, if I shim the tray here to make it slope gently upward, that will redirect the pushing block just enough to let it get into the blades. So I made these little shims, remove the screws, put these in there, reinstall the screws, and sure enough, that actually got these to clear the blades. But it also raised the heads on these screws just enough to make them gouge on the underside of the pushing block, still leaving little bits of aluminum in the tray. So what ended up actually working was going into one of my boxes of electrical supplies and pulling out some of these nylon bushings. So you use these with metal conduit, and you install this on the end to cover up any burrs and to keep them from cutting through the insulation on your conductors. So with the convenient little split in there, I could just pop it over without actually having to disassemble anything at all. And with the tapered shape it has, it kind of centers itself and takes up all the slack in here. So now it was a very sloppy fit before. It's actually kind of tight. Now I have two of these installed just by pressure, nothing I'm actually holding them in there. But with them there, when I pull the lever, boom. Now, for the moment of truth, I have 1/2 of a Joel sweet potato already peeled and faced off on this side to help it sit against the pushing block. I'll start with half, see if this works. As center as possible to give it a fighting chance. Okay. Oh, son of a dick! Ah. That was way harder than it should have been. But it worked! Success! These guys are amazing. And if you only do half a potato at a time, then it is a little bit easier. Still, I'm definitely disappointed in the overall build quality of the Vollrath, and the ease of use could be easier. So now I really just see it as a holdover until I manage to build myself a proper pneumatic-powered French fry ram. That won't be for a while though, so until then, the frycutter will do. I'll also say, if you're content with circle cuts, basically chips, then the mandolin might be the ticket for you, because with a mandolin, you can just slice these things in seconds. It's quick. And both of them taste amazing. Now, if you excuse me,